God have mercy.
Okay, so let's talk about the difference between a sequence and a series, because that is a very important distinction. A sequence might look something like that, correct? What are the terms of that sequence? Yeah, so the terms are
1 over 3, 1 over 9.
Sorry, my computer is having trouble keeping up with my busy intellect. Okay.
Weird flex.
What'd you say?
Weird flex.
I only can steal my material from the Princess Bride. Just wait till I get going.
Why is 3Q 29?
I don't know.
27.
What did you say?
I said 27.
See, my dizzying intellect. I was just trying to test you guys.
Sure, I said 27 though.
Sure you did. Okay, all right. What would a series of the same form look like? So this is term 1, term 2, term 3, right? Okay, series. Here we started at n equals 1, right? So the series go, and we always go, don't always go to infinity, but we can. The series means that we sum the terms.
You just want nothing. You're trying to connect them up. Breaking reference.
Okay. Okay, we've already studied convergence of sequences, so what would this converge to?
0.
Yep, the terms go to 0. The entire question of the rest of chapter 10 is how do we determine whether these converge or diverge?
The series converge or diverge?
Yep. So is there, basically what you're looking for, is there a bound to the sum of those terms? Okay. So when you add them all up, is there some upper bound or lower bound that never is crossed? Okay. So do we converge or diverge? That's the question of chapter 10. And there are those 9 tests I gave you the handout. 9 ways to figure that out. Okay, that we will learn. I'm sure there are more. Right. So.
Calculus keeps inventing new stuff every day.
No, it's the people. The calculus is always there. It's just waiting for us to catch up.
4 9ths. That's where it converges. No, that's wrong.
What?
Okay, never mind. It's going to be greater than 1/3, but less than.
Okay, so here's what's crazy. Most of the series that you see, you cannot determine what they converge to. You can only determine that they converge or diverge. Now that one's a geometric series, if we talked about geometric sequences. Mm-hmm. Geometric series actually have a formula you can compute what they converge to, as long as the R value, 1/3, is less than 1, right? But a lot of them, we can't even figure that number out. Okay. So, series have something called partial sums. Partial sums are important because they're how we determine divergence or convergence. Oop, let's edit that right there. And put an N, a big N.
That's big one.
So partial sum just takes a few of the terms and evaluates them.
What's that?
A sub n.
Okay.
Okay, so what would the sum sub 1 be? So the first partial sum would be the series from 1 to 1, which is only term 1, right? What would the second be?
From 1 to 2.
So you A1 plus, right?
Yeah. Let's see where we're headed.
Yeah.
The third would be A1, A2, and A3. The fourth, right? So those are called partial sums. What would the, well, we can use that series up there, right?
I'm just gonna get these
Oh, it's not that bad.
sterile. I'm the outlier.
If we use the series that we have up there,
Yeah, the tiny theater.
what's the first?
One
1/3.
third.
Okay. The second.
1/3 plus 1/9. Yeah, plus 1/9.
First and second, and then the third.
1/3 plus 1/9 plus 1/3.
Let's decimal those out and see.
0.33.
Okay, so we know what this one is.
4/9. Is it 1?
This is 4/9, which is 4 repeating. It's this one. 9.1 repeating plus
1.7?
No, 1/9.
Yeah.
13/27. Anybody have that on the calculator?
13 divided by 27.
Yeah. Should be close to 0.5, obviously.
0.4814 is repeating.
So it converges to a half?
Maybe. What's 4? Third plus a 9th plus a 27th plus a
27 times 3.
81st.
Yeah.
Just one person with a calculator. It's busy right here.
Sorry.
I don't have the answer in my book because I'm giving you something different.
27, 64.
81.
81 over 81. What?
1 over
81.
40 over 81.
40.
Just give us a decimal.
40 over 81,
Oh.
1 over 81.
Just do the fractions in your calculator and give us a decimal.
4928.
0.4928.
Yeah.
So I was right. Okay, so it does appear that these are headed towards, you think they'll ever cross it?
No.
No.
Probably not, but they might. But this does converge. Okay. But the partial sums are how we determine convergence. Okay. So,
How far do you need to go with partial sums?
to the infinite. So that's why we have all these tests.
But then it's not partial.
Okay.
You go
If the limit is then approaches infinity of the partial sums. So as these partial sums, if we kept going to infinity, what did they what is their upper bound? Maybe. Okay. So here's how we determine convergence of an infinite series. My computer being slow. So there's the statement.
Will we have the statements on our flashcard?
Yeah, we'll make flashcards for all this stuff. Here's the math. Calculus statement. The limit as n approaches infinity of s sub n is s. So mathematically, in this case, we would write it like this. So that will be converge, right? What if the limit does not exist?
And it diverges?
Series diverges. And we can also say if the limit
Doesn't equal that.
equals infinity, we can be more specific in our language. The series diverges to infinity.
So when you have like something equals a series, like the S equals a series, that's just showing when that series converges or out.
If it's a number.
the difference between diverges and diverges to?
Well, does sign diverge by that
Yeah.
definition? Maybe.
Sure.
Yeah, because it'll still diverge to a certain point, right?
No, that would mean converges.
Oh.
It doesn't go this way.
So, the partial sums have to converge to some number, right? But if you get a function that's, or a series that bounces all over the place, doesn't converge to one number, but it doesn't diverge to infinity, you can have something that diverges. Does that make sense?
So rarely cosine.
Alternating series. Yeah, I think that would be a correct statement.
They're very particular, they have their own rules for it.
Well, we have to make these rules. Otherwise, we don't have any boundaries to operate
Sine and
in.
cosine has that their own.
Well, they're periodic functions that don't follow an alternating pattern. They do alternate, but not by the way the alternating series test requires. Okay, next, let's look at the telescoping series. So I told you there are some famous series. Here is one of them.
What's that one thing? Yeah, exactly the one thing. Like it was the-
Sure.
the
I have no idea what you're talking about.
Super famous thing.
Can you watch this here?
Yes.
If you were here the other day, you would hear the discussion.
No.
I mean, you're not.
Turned around too
but
fast.
You are.
Okay, that's called the telescoping series. We are going to investigate it numerically, since that's really the only tool we have right now. But we can show what it converges to using a numeric investigation.
What are the other tools?
What was the 9 tests that I gave you
Oh, yeah.
that we haven't studied yet?
Well, I don't even understand how you test it, it's just like.
It just has to meet the terms of the test.
Because like for geometry, it just says, we'll converge it, and then it gives you.
Yeah, you meet the terms of the series test, then you converge it. If you don't, you diverge.
But
That's
then how
it.
do you figure out where it converges?
I told you, most of them you don't.
What?
Geometric, there's a formula. Okay, but most of the others, there's nothing. If you just know it converges, you just don't know what to. It's very difficult to show, or impossible in many cases. So a numeric investigation I showed you already. So what would the first sum be?
1/2.
1/2. The second,
1/6.
half plus a third, right? Half plus a sixth. Right. The term 2, plug 2 in. We have the first term, and then plug 2 in, so 2 times 3, 1/6. About the third term. Half plus a sixth plus 12. Alright, so let's get decimals for all those.
That's my fair share.
You are genius.
166.
166.
No, that's 26.
No. This is
That would be
Point 1666666 plus
Yeah.
0.5. Okay, what's the next one? 0.083. 0.08333333. Added to that.
0.7423.
Ish. Okay, what would the fourth be?
128.
3.
Okay, add another term to that, Hunter.
Wait, why didn't S14 go on?
It did.
130.
What are you talking
7.43 and 7.93.
about? Your 4 is at the pins.
My 4 is slightly up. This is not up at all.
You getting offended showcases
.826.
Okay, next.
Yeah.
Just hit plus and then the next term.
And then next thing, 2850.
Is it showing any signs of slowing down?
No, I think
This telescoping series, in fact, does sum up to 1.
Oh.
Now, how do we determine that going decimal? You gonna go on forever and ever?
Pick a really far number and just do that.
Yeah, that's what I
Oh. Like, why did it go one by one shot?
Just for like.
But you have to add up all the terms.
Oh, yeah.
Well, it's the
You still have to plug it in.
Yeah, that's what
It's a calculator.
There is,
There has to be a feature on the calculator.
there's a way to do this one without doing the decimals, but I'll spare you. Okay, so that would be a numeric investigation.
Yeah, you can populate a list in your calculator.
Pretty sure there's a,
And then do the sum of the list.
pretty sure there's an E on this.
There's me.
Well, yeah, but then you still have to plug in each thing.
There might be a series
Am I?
button or in there somewhere. You never use it, but. Let's compare a series and a sequence.
Series and sequence.
Yeah, so, well, let's use the previous one. Okay, that is a series. The sequence would look like this.
Summation, right?
Yeah.
Got you.
Right?
But you
So
can't
this
put it in
converges to
there.
1,
Oh.
correct? I just told you that.
Yeah.
What does this converge to?
1. Is that R plus 1 or N plus 1? 0. So if
So
the
sequences and series do not always, or hardly ever, actually converge to the same thing. Because you're adding here, you're only going term by term
but
here.
if a sequence converges to 0, that shows that the series probably converges to the numeric.
Not always.
Why?
Because there are series that do not converge, that the sequence goes to 0.
Like what?
A harmonic series is a fine example.
That's a brilliant segue.
Thank you. This is actually not planned for today, but it's good. The harmonic series diverges.
I like harmonic, isn't
The sequence converges.
it? Doesn't make sense, doesn't it? Wait, you say n equals -1 or 1?
That's 1.
We lost it.
Okay.
I feel like that should
Okay.
still converge.
Well, feelings can be deceiving.
Enlighten me on my...
What you're experiencing here is something that doesn't make sense, but it is true. Okay. It does. So what you're seeing here is that in order for a series to converge, right, the sequence must converge to 0. Remember we talked about converses and inverses and contrapositives?
Yeah.
If a sequence converges to 0, it does not mean that the series converges. Okay? That's the example that blows that whole thing up. It's called a counterexample.
But why doesn't the harmonic series converge? I feel like it should.
Why does it diverge?
Yeah. I feel like that should definitely converge.
Like I said, feelings. How do we show it diverges?
Yeah.
The nth term test. If the nth term a sub n does not converge to 0, so if the sequence does not converge to 0, the series diverges. It's a theorem. Now, why does that theorem work?
But the sequence does converge to 0.
The sequence does.
Yeah.
But the series
So
does
it
not have
says
to.
the series, the nth term testing, if the limit a sub n as an approximity does not equal 0, but it does equal 0.
Right, if it does not equal 0, if the sequence doesn't converge, then we know the series doesn't. But we can't say anything about convergence using that. So we can't say the sequence converges to 0, so the series converges. That's not a part of that theorem. We will talk more about it tomorrow. So we're out of time. Tomorrow I'll show you geometric series and what they sum to, and we'll talk about the nth term test. If you can show the limit as n approaches infinity of a series, a sequence related to a series diverges. It doesn't even have to diverge, it can go to 1. If it does not converge to 0, your series diverges, period. Okay. So that's tomorrow. I'm pretty sure this is a 2-day assignment, so I'll write it up. Yeah. What?
What grade are we in 2013?
Well, since you act like you're 5 years old now, that would mean you didn't exist.
Seventh
Or what happened to on leap year? No.
Again, you have
Only
like
one person I've met.
till Tuesday on this, so don't do it all Monday night, because
grade.